Balaji. He worked in Singapore and Australia as a technical consultant for about 2 years. In India, he worked as an assistant professor in the Department of Aeronautical Engineering for Hindustan University about 4 years and as an instructional designer for 3 years in India. He has completed dual masters in India and Singapore. In Singapore, he has done his Master of Science in Precision Engineering with specialization additive manufacturing and also Master of Engineering in Aeronautical Engineering. He has published 8 Indian patents in mechanical, aerospace and manufacturing.
Welcome to UGC lecture series on additive manufacturing. In this session, we are going to discuss about solid ground curing. The contents which we are going to deal now, how the solid ground curing is going to be processed and what are the process parameters associated with that, and how the process can be optimized, followed by some of the latest trends in additive manufacturing. Compared to other process, here it has the phase change with help of material curing. So the particularly how the material is supposed to be, it should be in a tendency to cure instead of melting or sintering, right? It has the capability. So what kind of material we prefer to go for? Some kind of photopolymers, right? Photosensitive materials or photopolymer materials. So that is the major difference here in this system. As we have seen in SLA, some of the photopolymer materials, right? So in that one we have different in input, that is the laser is going to be the input in that case. Here we are going to use UV lamp. So that is a advantage in this, and this has been developed by the company which is Cubital Inc. of Israel, right? What are all the steps involved in it? How it is going to be processed? What are the steps involved in it? So you can see some of the process parameters, starting from the first one is how the mask is going to be generated. This mask is generated as like other AM systems, we need input from STL file. So that is a common fundamental, like generating 3D diagram followed by STL files, and that is going to be the input for the mask development here. So that is a difference between other systems and this system. The first step is how to generate a mask. That is number one. So this is second one is applying of liquid photopolymer layer on the top of a layer where it is going to be processed, followed by this glass mask is placed over a material, and then this lamp, the UV lamp, is going to give the thermal energy to cure the material, right? Followed by removing unwanted polymers which is deposited over it. Finally we are applying wax on top of it, and then we are using milling process to take the excess amount which is deposited on the top. So this is process. Is it clear? Like as we are starting with mask preparation, the mask material is preferred to go for glass because we can change easily once it is being processed. Each and every layer we don't want to go for a different kind of mask. So if you are going for a glass kind of material, we can easily remove and we can deposit other layer on top of it itself, and then we can keep on processing till the component is being developed. So that's why we are going to prefer to use glass kind of material, right? Followed by simple, like we are going to apply use with help of some rollers or whatever on top of it, which is going to whatever layer it's already been deposited, on top of it we are going to apply this photopolymer material, right? And then just we are placing on top of it, you know, the effect of mask, only that particular area is allowed to be cured, rest of the areas is going to be restricted. So that is going to form a entire shape. And finally we are taking the excess, that is polymer, which is uncured, right? In this process we are taking the uncured polymer with help of, preferably they are using vacuum cleaners or something, some kind of thing, which is particularly why they are using vacuum. They don't want to give additional impact of using some other materials. If you are going any other material using some normal cloth or whatever, it may leads to some form of dust formation to that particular area. So they prefer to go for vacuum kind of thing. So, and finally they are applying the wax, which is going to act as a support, right? Why we are going for applying wax on top of it, that is going to act as a supportive material. We don't want to go for any additional support. The wax is, you know very well, once we are applying, we can easy to remove compared to other materials. And also this photosensitive material, it's, if you are using some other material, it may leads to what will happen? Cross contamination of the material. So that process also that can be avoided if you are going for wax kind of material. And also it's easy removable. And then if there is any excess wax is deposited or excess material is deposited on top of it, based upon the layer thickness, this milling is going to take out your excess material, it's going to remove. But here, as I have said here also they are using vacuum along with while they are doing the milling process, because as I said, if they leave out any material, even there may be possibilities of any dust or burrs from milling cutter itself. So those possibilities are there. They don't want to leave it on it. Immediately once the process is done, along with that they are going to use vacuum pump to suck out all the dust, whatever may be in it. So this is how the steps has been defined for SGC process. In some they are mentioning it as solid base curing. That depends upon what is the, mostly that varies, depends upon the manufacturers and company. Mostly some of them mentioning it as solid base curing, some of them are mentioning it as solid ground curing. So that particularly depends on manufacturers and the words they are using. And then followed by the process parameters. Here you can see only the major factor is 3, particularly the masking and UV light and then the milling. These are all some of the parameters which may leads to defects, right? As I said, like this is the major contributing factor for the product development compared to, like, we don't have any other, like applying removal, that really not going to affect the product much, but these 3 is going to affect the product development entirely. So these are all some of the parameters associated with that. So as I start with masking, what is the thing? It is going to generate the component based on the layer input, right? That is a major thing here. Based on the layer input, I can just deposit what are all the, like as you've seen, some of the component development we need to go for a negative image of it. You can identify, right? Because why? I need to use this as a mask, and the negative impact is going to leave out your defined component. So the masking will be always a negative image of the component developed. Like if you need a E like this, it should be another way around. Then only we can get the component impacted on it. So layer buildup is based on masking. It can, each and every time we need to change it according to the defined component developed, right? It may be of n number of shapes, so accordingly we need to change it, right? Followed by how much time it is going to expose, right? Even we are using glass as a masking material. What will happen if we are keep on exposing more UV light? There may be possibilities of, one, initially it may, the glass may get heated up, another way around, it may allow the light to passes through, it may cure some of the other photosensitive materials as well, right? So the exposure time really matters here, how effective it is going, because only it has to cure only the where it is exposed, only the exposed area is supposed to be cured, right? If we are using, particularly if we are making uncured material which is not going to be involved in product development, that may get cured. In that case, we really lose our defined shape or component development at all, right? It's very, very harder in that case. So we need to be consider this factor as a important factor as well. And then while milling, right, we need to know only the excess amount of wax or material should be removed, because it really doesn't have any control from layer, that is from STL file. So if we are doing additional milling, what will happen? It may take up the layer, and that is undefined, that is predefined data to the STL file. It is started building up next layer, right? It is keep on going in sequence. But if you are taking out or removing some excess material from the layer, entirely leads to defect to the entire material. We may not, because this is not rely on the STL file. This is a manual process, or maybe like automated process, but it is also not exactly rely on STL layer input. So you need to be very careful while doing this operation as well. So how this can be optimized, how this can be effectively managed, like masking. While defining each and every layer, we should be very careful, because that is going to define your layer, right? That is maybe if you are going for higher level of development, like particularly if you are going for little distortion or there may be some changes in the shape, that will directly give the impact of component development. So initially while laying up itself, we should be very careful. The dimension should be 100% accurate, right? Or otherwise this will entirely going to change the shape of the component development, right? Even you can see some of the components which is very minute areas, and additionally we are not using any standard supporting structures as well. The supporting structure is additionally applied with the help of wax. So here you see the involvement of manual is comparatively higher than other processes. Like we need to manually apply the photopolymer layer, and we need to apply manually the wax, and then we need to take off the extra applied materials, whatever may be, using milling process. So involvement of manual is comparatively higher. So we should be careful even starting from each and every layer deposition. But one advantage is each and every layer we are sizing it up, so like on time process we can monitor, like on time monitoring can be done. But for that the person should be very skilled. But mostly nowadays this process is not effectively used. We can say almost the process got obsolete. In the year 1991 they have developed, I think, and almost in 2001 they are not commercially using it for most of the process, because you know the SLA is comparatively easier to manufacture. That is very easy, right? Even some of the trends they have developed to a much higher level from the normal SLA. Even today I am going to discuss about that in current trends. So the process has gone to very extreme or different state now. So we should be very careful while involving the manual work. So here we should avoid that while developing itself, right? The first thing is effective mask development. This is going to give the initial imprint to the material going to be cured, and then followed by UV light exposure. That is, as I said, the problem is if I have high level of energy supply with the help of UV, it may what will happen? It may uncure the material, that is which is not involved in product development, may be get cured, right? Or if it is exposing for more time, there may be possibilities of glass absorbing higher temperature, that may leads to phase change of the material what we are using. Or it really doesn't require to change the phase entirely, but there may be possibilities of some contamination or problem for the photopolymer materials. That should be avoided, right? If it is very low, it won't cure properly. What will happen? If it is not cured properly, while taking off the excess material, the uncured material may go off, right? Because what we are doing, once it is being done, uncured material can be vacuumed and we are taking it out, right? If it is even left, even small material which left over like a uncured material is being taken out, because we really don't have any control of the layer, because we are taking it off manually. So we should be very careful here. That's why they face so many problems. That's why they are not using for commercial purposes. And then followed by the milling. Milling can be done, as I said, to remove the excess surface. And the advantage here is if there is any uneven surface, that can be make it flat in this condition. So that is a advantage in this one. And the supporting structure also, it's going to be with the component for throughout the development, right? There won't be any internal material change or distortion, or it may leads to uneven surface movement may not be occur, because we have solid support throughout the component development, and also it's not like supporting only at the particular area. So that is a major difference in it. It is going to be add up along with the material for the entire process, and even there may be any irregular shapes, it is going to be occupied. But the problem is if the material, the shape is very difficult, and it's very, sometimes if the shape has a number of internal cavities and holes, in that case it is harder, So that is one of the problem associated with. But material they are using, they may heat or cool to take out the waxes. Particularly if the material they are using, it has been cooled while applying on it, right? What will happen if you want to take it out, we can increase the temperature to a particular level, we can remove it off, but it should be lesser than the optimum working temperature of the photopolymer material, right? That is one of the, you can say, that is hard part in it. So we need to avoid those kind of errors associated with that, right? So how we, if any other possibilities for that to make it perfect in this system? What are the disadvantages you feel? Some of the disadvantages I said.
Sir, I have a basic doubt here, sir. Sir, in the process you have mentioned around 6 steps,
Yes.
and these 6 steps will be repeating for each and every layer. Is it right, sir?
Yes.
Okay. Sir, the liquid photopolymer, when it is applied for each layer, how it is applied for each layer, sir? It
So
cannot
as I said, it involves more manual process. Each and every time they need to roll up the material. They may not maintain 100% flatness even.
How they can control the layer thickness when they are applying it manually, sir?
No. Layer thickness, the material deposition is based on the mask. They have some defined material amount of input, but that's what I said. 100% we may not maintain exact amount. There may be some excess and below, but they are controlling like a material which has additional stand kind of support. It won't leave out more material. It will leave out exact level what they really need, and that is almost a manual kind of thing.
Sir,
there is no 100% possibilities to get a exact amount of layer thickness as we do it in other AM process. That's what I said. Involvement of more manual thing is here.
Okay. The first step, sir, the mask is generated. Generally, we use a material, glass-like material.
Yes.
So, how the pattern which is to be replicated on the layer has to be etched on the glass or something like?
No. Like say for example, some material which is not allowing the light. Like I am making it as opaque. Instead of transparent, translucent, it won't allow the light inside. That's it. They'll make the layer accordingly that the portion which is going to be generated, that part they will leave it transparent. Rest of the area they will cover with some opaque kind of material. It won't allow the light. That is the basic phenomenon. That's what they may not allow the light for more time.
When they are allowing the light, sir, we have studied a basic 2 kinds of masking, sir. One is for positive resist and negative resist. But you have mentioned something called reversible or something. You have mentioned like with an example called E. Suppose we want an E-shaped pattern. The E has to be printed like in reversibly. How is
like say for example in this case you can see this is like as same as we have, right? Because the component as it won't shape. Some material as it got internal changes in the shapes, right? But the mask is going to be placed in a same manner. Always plus. In this, say for example, this is state 1, state 2, state 3, but the position will be same. Each and every time if I change the mask, what will happen? The material positioning may affect the layer. That's why they prefer to go for reverse imaging in cases where they need to deposit. That's what, that purely depend upon the defined shape. The shape may be in this case maybe here, and next layer may be in reverse manner. So if they go for a negative impact, they don't want to change the placing order of the classes, certainly placing order of the mask.
So in this example,
this is open.
We have patterned like a cylinder. So here the unwanted material is the cylinder. That is, the cylinder has to be removed. So only we are applying wax on the cylinder patterns.
No. See, here you see this is the area, right? This is going to allow the light inside, and that part has been cured here. Can you see the difference? So this is going to be come out like a cup. Impacting of resist is totally different from here.
Okay.
Right? Okay. Here you forgot that concept itself.
Okay.
They are going to give some they are going to allow the light in such a way that it is going to give positive image or negative image. That depends upon the component development. That's all.
Okay.
But the process is straightforward. This is going to, wherever it is exposed, it is going to supply the light. That's supply the energy. That's it.
Okay. So we are developing a cylinder pattern, cylinder shaped object.
This one here is it's going to be act like a cup.
Okay, something called cup. So when we are patterning first layer, we are patterning a circle.
Yes.
So we are patterning a circle, and where and the circle exactly where the pattern is there, the photopolymer is going to be cured, and the remaining portion is uncured.
Yes.
So immediately we'll be removing those uncured layer,
Yes.
and we'll be filling with wax, right, sir? And the areas where the wax is filled is getting trimmed by milling.
Both, even the excess polymer is there, cured polymer is there, that is also going to be removed.
Okay.
The problem is, say for example, I think you are trying to ask this one. If the surface is totally flat, right, the bottom face of the surface is completely filled, right, in that case the wax is going to be filled around it.
Yes.
So not exactly on the top of it.
Okay.
So that's what I am trying to explain. Based upon the layer, we are going to fill the wax. Again, the wax filling also is like a normal phenomena. They will use a roller which will give the required amount of wax in it. Just they are closing it.
Okay.
Finally, that process actually, if you want, you can include here all. Like after applying the wax, they prefer to go for some cooling plate by keeping on top of it, just to make it condense. So mostly the layer, based on that, this is going to fix up entire processing of the component, right? Whatever may be the irrespective of shape.
So this post-processing, the milling process, sir, is it feasible for using milling as a post-processing process?
That's what we
the
can do.
That. Okay.
That's what we can go for milling. The problem is, if the labor is unskilled, in that case for sure it will lead to damage, and as well as the material is very, very thinner, so you have a doubt of why we need to go for milling. It's true, we can go for alternative methods, even better alternative methods. Even the worst case, you can use wax curing with the normal threads even. That is better. But the problem is, they are followed this method. That's why it has got some controversies. They are not using at the moment.
Okay.
So it has some internal problems associated with this.
Okay. Okay. Thanks.
Okay. So, and followed by, these are all some of the optimization can be done. So as I asked, he has pointed out some of the disadvantages. We have many disadvantages with this system. That's why they are not really used to develop this concept. They move to SLA system, as I said. So the trend which I have seen recently, that is the SLA Boat 1. It is being developed by 3D system, right? It's one of the advanced trend. They will try to do it with the help of SLA. You know, SLA has been developed long back, but now what they did, they completely automated the system, including the post-processing. You can see the component is developed 100% with the help of automation. You know what are the post-process involved? Sometimes we need to make it cool, we need to use some hard baths or cold baths, sanding, or whatever may be the process. So what they have did, the 3D system, they developed a entire automated system for a SLA process. You can just watch this video, it will give some clear idea about it. If you want to stop somewhere, please just raise your hand and stop it. As I said, the secondary process, first they are washing, again they are taking to the curing station. And the photopolymer they have used is biocompatible. I hope now you understand why they are using it. So you can see how they automated the complete process. Now for SLA, what they are claiming is they don't want any additional manual input at all. even we don't want to do any post-processing process. Mostly the material is photosensitive. As we know, only that particular layer we are going to make it as a component, and as well as you can see how fast it is. They have mentioned it as ultra fast mechanism. Comparatively, not like other SLA processes, this is really much faster than that. So each and every time the component built up can be attained within a very lesser time period compared to normal processing time. So effectively they did, as well as they automated the post process, right? So we don't want, particularly you can see the materials, it is very harder to do the post processing manually. Even if some supportive structures we are building up, it's very hard to do the post process. But here they are claiming the supportive structures also can be avoided, or they are mentioning in another way, the supporting structure, if it is there, they may do automated post process to eliminate it, because it's very recently published. So they really, I don't have any additional material to refer, but in this case they have claimed these two statements particularly related to supporting structure. So you think it of the entire process is built up in a single step. It's very easier for us. That is, we have seen some of the AM process, some of the disadvantages we mentioned, that we need additional post processing, right? In so many cases we have discussed. That's why I would like to share this information here, because the post processing is really a hurdle kind of thing for a AM process. So that is been eliminated, or that can be eliminated to the maximum level with the help of this kind of post processing system. As we have discussed in some of the classes, we can introduce some of the online monitoring and post processing automation if you have any plan of developing those kind of things. So this is like one of the real research area where you can include some of your ideas, particularly even not alone concentrating only on manufacturing, you can focus even in post processing development. That is being automated in such a way. Some of the more post processing are really very harder. As I said, surface finishing is, if it is a metallic material or ceramic material, it's very harder to get it done. So if you are automated that is really is very useful. So in case of any idea of developing some areas in such a way, you can even concentrate more on post processing as well. Okay, in this session we have discussed about how the solid count curing process is accomplished, followed by what are the parameters in it, how effective the parameters are involved, and finally how the process is being optimized, right? Finally, at this last stage, we have seen some of the latest trends in AM process, particularly the trend related to SLA process, one of the effective curing method for component buildup. Okay, please note on these questions. Describe in detail the process steps of SGC. Describe in detail the process steps of SGC. Explain the process parameters associated with the SGC. How to optimize the SGC process. Anyone have any question? No?